For the second, you subtract 10x. Can you subtract 10x from 12? No, so you write them next to each other. You divide by 6. And then you want to make sure you reduce. What is negative 10 over 6 reduced to?
Negative 5/3.
Negative 5/3 x, and then 12 over 6 reduces to 2. So you compare these two slopes. We got 3/5 and negative 5/3. Are they parallel, perpendicular, or neither? Perpendicular. They are the opposite sign and flipped of each other. The second thing you're going to write down on this paper, you'll also need to be able to look at two sets of points and decide if they are parallel, perpendicular, or neither. I'll give you a second to write them down. So how do you find the slope between 2 points? Over. Good. All right, so what is my first y? Negative 2. And then my second y? Negative 7. When I plug in negative 7, there's already a minus there. That makes a plus. My first x is 5. My second x is 3. Is 3, yeah. What's minus 2 plus 7? 5. And then 5 minus 3 is 2. So we're going to do the same thing below using y1 minus y2 over x1 minus x2. My first y is 5. My second y is 3. My first x, negative 3. My second x is 2. 5 minus 3 is? 2. And then minus 3 minus 2, negative 5. So are these parallel, perpendicular, or neither? These are perpendicular again. They're the opposite sign and then flipped of each other. So at this point, we're going to go to page 3. Great. You should see this at the top. In this section, we will have fractions, and you'll need to know how to multiply them. So we're just going to practice a few times. When you multiply fractions, you can multiply straight across. That's the only way to multiply them. 1 times 5 is 5. And then 2 times 4 is 8. Can this be reduced? No, that's it. The second one is really what you're going to see. A fraction multiplied times a whole number. What do I have to do to the whole number first?
Put a 1 under it.
Put a 1 under it, right? And then 1 times 8 is 8. And then 4 times 1 is 4. This can be reduced to 2. There is this thing called cross-canceling you can do. So cross-canceling would have looked like this. You look across and see if there's anything they're both divisible by. So 4 and 8 are both divisible by
2.
Not just 2, but also 4, right? So you could divide 4 divided by 4 is 1, and then 8 divided by 4 is 2. And then you would have multiplied straight across. 1 times 2 is 2, and then 1 times 1 is, which would end up being 2. So you can cross-cancel if you choose. And then the last, what is 10 times 11? 110. And then 3 times 6, 18. They are both evens. This can be reduced. Divide by the number 2. What is 110 divided by 2? 55. And then 18 divided by 2 is 9. Can they be divided any further? No. That's it. So just reminding you how to multiply fractions. So what's going to happen is you're going to be described a line, and you'll have to find the equation of the line. So there are 3 steps to doing that, and you'll see them in the middle of the page. It'll say 1, 2, 3. The first step is to find the slope. Step 1. Let's go ahead and write it in. Find the slope. You will want 2 highlighters here in a second. So find the slope. There are 3 situations you would find yourself in. The first one is you're given 2 points. If you're given 2 points, how do you find the slope? If you're given 2 points, how do you find the slope? Yeah, the formula. The y1 minus y2 over x1 minus x2. So if you're given 2 points, use the formula, the slope formula. If you are told that your lines are parallel, what do you know about the slopes of parallel lines? They're the same, right? So that would be the same as the slope that was given to you. Or you could be told that your new line is perpendicular to another line. So what would you know about their slopes? Opposite sign and flipped. So those are the 3 situations you'll find yourself in. We're going to do an example of each, where you'll have to find the slope, and then parallel slope and perpendicular. This second step is going to be the same across the board. You will have a slope and a point. There is a formula for that. It is the last formula we do in this section. So I will show it to you. Step 2, you're going to plug 1 point and slope into the point slope formula. You plug in 1 point and slope into the point slope formula. Point slope formula. This is why you have 2 colors. Go ahead and highlight the word point in one color and the word slope in another color. Because when I show you the formula, you're going to highlight where you would plug in the point and where you're going to plug in the slope. So highlight the word point in one color and the word slope in another color. Point and slope. All right, and here it is. Y minus y1 equals m times x minus x1. So when you write in this formula, this is where, your highlighting mattered. So your point, mine is in red, so you'll see where you plug in the point. And then I wrote the word slope in blue, and the slope is represented there in blue. Everything else that's in black, you don't plug anything in there. It just stays. And I will show you where this comes from. So the actual formula is y1 minus y2 equals m times x1 minus x2. This should look pretty familiar, right? What was the slope formula in the beginning? It's on the page. The slope formula?
It's
y1 minus y2 over x1 minus x2. So if you see, they took this formula and they rearranged it. What did they do to go from here to our point slope formula? They multiplied by x1 minus x2. So I promise there's, a rhyme and a reason for everything we do, and it all comes from, the same idea. We don't write y1 and y2 because you're not going to plug anything in to this y or to this x. You leave them like that. Because our last step, what do we want our answer to look like? An equation of a line. Yes, which is y equals ms. Yeah. So go ahead and write that you want to solve for y. You do want it in slope-intercept form. I'm proud of you for knowing those words. You're just going to solve for y. That is your last step. Solve for y. You have blanks above, just showing you what they are. What's the first one say? Is that one point slope?
Yeah.
Mm-hmm.
Yeah, so point slope is where we plug in a point, we plug in a slope. That's this one. So that goes in your top blank there, in the middle of your page. Right there. In the middle of your page, middle top of your page. Is the y minus y1 equals m times x minus x1. And we call it that because we plug in a point, we plug in a slope. Slope-intercept. What is slope-intercept form? Y equals mx plus b. Which of these letters represents the slope? M. And then which of these letters represents the y-intercept? B. Which is why we call it slope-intercept form. So we're going to practice. At the bottom of the page, or middle-ish of the page, we're going to find the equation of the line through point 4, 6 with a slope of 2. So our first step is always to find the slope. Do I need to do anything to find our slope? No. So I found my slope, right? My slope is 2. So done with step 1. Step 2, we're going to plug in a point and a slope into point slope formula. So y minus y1 equals m times x minus x1. So remember this y minus, nothing gets plugged in for that. So I'll put y minus and then a blank. And then something will get plugged in for my slope. And then we have x minus, and then we'll plug something in here. So what is the y that I will plug into this formula? 6. It is the y of the coordinate, so 6. And then we said our slope was what? 2. And then my x coordinate is 4. So we plugged in. Now it's solve for y equals mx plus b. Solve for y. So what do I need to do next? Distribute. The left side will stay the same. 2 times x is 2x. 2 times negative 4, negative 8. Add 6. And y equals 2x minus 2. Do you guys remember Desmos?
Yes.
You'll use it tomorrow. It's okay. You don't have to remember it. So I will show you what we just did. What was the point that was supposed to be on our line? At the beginning it said what point? 4, 6. And then we ended up with y equals 2x minus 2. All right. Does our line go through that point? It sure does. Perfect. So tomorrow on Big Ideas, it will ask you to graph to check. You'll just open up a new slide or a new tab, and you would type in both your answers so that you could graph. So that's our first example. Our second, we're going to get a little more difficult. Same steps, though. We want to go through these 2 points, and we want to find the equation of that line. It says find the slope. So what do I do to find the slope if I know 2 points? y1 minus y2 over x1 minus x2. We have to find the slope using the slope formula. What's my first y? 8. And my second y? 2. First x, negative 7, and then my second x, negative 14. I plug it in, and there's already a negative in the formula. So that makes a plus. 8 minus 2.
6.
And then minus 7 plus 14. 7. So we just found the slope, and it is 6 over 7. So now we're going to plug in 1 point. So notice how I said 1 point. 1 point into the point slope formula. You can pick either one. The only wrong answer is like mixing and matching. You can't pick an x from one and a y from the other. You just have to pick one coordinate point. I usually pick the easier one, which I would think would be this one. Just smaller numbers. You don't have to deal with the 14. So I am going to plug in this point. If you had plugged in negative 14 too, you still would have gotten the same answer as we're about to get. So we're going to plug in our point and our slope into point slope formula. Y minus y1 equals m times x minus x1. All right, so what is my y that I'll be plugging in? 8. And then we said our slope was 6 over 7. And then my x coordinate, negative 7, which will turn into a positive. So we plugged in this coordinate. We plugged in negative 7 and 8. We plugged in our point. Now we're going to distribute. So y minus 8 equals 6 over 7 times x is 6/7 x. And then 6 over 7 times 7, you can put 7 over 1. You can come off to the side. It will be that. I am recording, so I do have to explain it. What is 6 times 7? 42. And then 7 times 1, which reduces to 6. You could have also cross-canceled and seen that 7 and 7 are both divisible by 7. So that would have made 1 and 1, and 6 times 1 is still 6. My only word of caution to you is making sure you get this sign correct, because a lot of people will get the number right and then the sign wrong. We multiplied a positive times a positive, so this time we will obviously get a positive, but just be careful of that sign. My last step, add 8. So then we get y equals 6 over 7x plus 14. All right, so I'm going to show you again on Desmos. What were our 2 points? -7, 8. And then what was my second point? -14, 2. So we want a line that goes through these 2 points. I'll zoom out. There they are. And we found that it was y equals 6 over 7, x, and then what was it? Plus 14. Ta-da! Beautiful. So that's why tomorrow it's going to ask you to graph to check. This is what it would look like. Questions about this one? Good. You can turn the page. So we want to write an equation of a line through the point 8, -2. That will be parallel to this line, y equals 1/4 x plus 2. So what do we know about parallel lines?
They have the same slope.
They have the same slope. So is this written in a way I know the slope?
Yes.
Yes. What is the old slope? 1/4. What is parallel to 1/4? 1/4. So our new slope is still 1/4. Got that going for us. Now we're going to plug in 1 point and the slope into the point slope formula. So y minus y1 equals m times x minus x1. So my y coordinate is -2, which will turn positive when I plug it in. My slope was 1/4. And then my x is 8. Y plus 2 equals 1/4 x. What is 1/4 times -8? Yes, what kind of 2? -2. It's a positive 1/4 times a -8. So we get a -2. And then my last step, subtract 2. So y equals 1/4 x minus 4. 1/4 x minus 4. So we'll look at it again. What was the original line? Y equals 1/4 x plus 2. And then our point that we wanted to go through? 8, -2. All right, so this was what we wanted. We want it to be parallel to this line, but go through this line or go through that point. And we found y equals 1/4 x minus, what was it? Minus 4. So, perfect. We have one more like this to do together, and then we learn our last thing. We want to go through this point and perpendicular to this line. So what do we know about perpendicular slopes? Opposite sign, and they're flipped, right? So is this written where I can figure out what the old slope was? Yes, it was. Well, it was -5. So I want perpendicular to -5. So opposite sign, so positive, and then flip it would be 1/5. So this is going to end up being the slope we use, 1/5. We found the slope. Now we're going to plug in to a point slope. So my y coordinate is 3. Then my slope was 1/5. And then x, -5, which turns into a positive. So we got y minus 3 equals 1/5 x. And then what is 1/5 of 5? 1. Is it positive or negative? Positive. Add 3. Y equals 1/5 x plus 4. I wrote it. Oh yeah, you wrote it. I see. All right. So it's not our last time, but I'll show you on Desmos again. What was our original line?
Y equals -5x
Plus 1. Okay, and then we wanted to go through point -5, 3. And then we need to be perpendicular. So we got y equals 1/5 x plus 4. So there we are. So they intersect, and they form 90 degrees. So perfect. At the bottom, we practice naming a parallel and perpendicular slope before we move on to the last concept. So the first, is it written in a way I can figure out the old slope? Yes. What is the old slope? 3. All right, so what is parallel? I'm going to write PAR because, you know. What is parallel to 3? 3. So M would be 3 because M represents slope. And then what would be perpendicular to 3? -1/3. So the opposite sign, and then you flip it. The second one, is it written in y equals mx plus b? No. So what do we need to move? Subtract 3x. So 4y equals -3x plus 12. Divide by 4. Y equals -3x over 4 plus 3. So what is the old slope? -3/4. So what is parallel to -3/4? -3/4. And then perpendicular to -3/4 is 4/3, 4/3. The last one, what is the only thing you need to do to get y by itself? Divide by 6. Divide each of them by 6. What is 2x over 6 reduced to? 1/3 x. And then minus 4 over 6 reduces to? Yeah, -2/3. So if you don't like the way this looks, you can put y over here. But either way, what is the slope of the old line? 1/3, which would mean parallel to that is 1/3. And then perpendicular to that, -3. So we are going to flip to the next section. All right, so we're going to talk about perpendicular bisectors, which is the blank at the top. A perpendicular bisector is a line that is perpendicular to a segment at its midpoint. So it is a line that is perpendicular to a segment at its midpoint, which is the top blank. It is a line that is perpendicular to a segment at its midpoint. So we're going to find the equation of a perpendicular bisector. The only thing that is in addition to what we've done is that we need to go through the midpoint. So if it doesn't tell you what the midpoint is, guess what we're going to have to find? The midpoint. All right, so there are 5 steps. We'll write them in this box here. The first step, the first thing you want to know is if we're going to have a perpendicular line, we should know the original slope, right? So the first thing we're going to do is find the slope. So find the slope, that's step 1. So find the slope. So in doing this, we can then find the perpendicular slope, which is the one that we will have to use to find the perpendicular bisector. So step 1, find the slope. Step 2 is find the perpendicular slope. So once you know the perpendicular slope, then you need to know what point you're going to plug in to the point slope formula. And that would be the midpoint. You will have to find the midpoint. So find the midpoint. After that, you have a point and a slope. You're going to plug it into point slope. So you're going to plug in the midpoint and the perpendicular slope into the point slope formula. So you're going to plug in the midpoint and the perpendicular slope into the point slope formula. So you're going to plug in the midpoint and the perpendicular slope into point slope formula. And then how do we want our answer to look? Slope intercept. So y equals mx plus b. That's step 5. Rearrange it, solve for y. Y equals mx plus b. That's it. So we're going to write an equation of the perpendicular bisector of the segment with the endpoints -2, 3, and 4, 1. So the first thing we want to do is find the slope. How do you find the slope between 2 points? Yeah. y1 minus y2 over x1 minus x2. So my first y,
3,
second y,
1,
1. First x is -2. Second x is 4. 3 minus 1 is 2. And then -2 minus 4 is -6, which reduces to -1/3. So we found the slope of the segment, but we want the perpendicular slope because our perpendicular bisector will be perpendicular to this one. So what is the perpendicular slope? Is 3. So that means perpendicular is 3. I would highlight it or maybe put a star next to it so that you remember which one you're going to use. You're going to use the perpendicular slope here in a second. We'll use that 3. The next thing we want to do is find the midpoint. You can use the formula, or you can try to think about it, and try to find the middle point. You could definitely do it easily with the y's. What is between 3 and 1? 2. If you can't figure it out, like in your head, you can always add the x's together, divide by 2, add the y's together, and divide by 2. So what is -2 plus 4? -2 plus 4 is 2. Divided by 2 is 1. It'd be a 1. Because 1 is 3 apart from 4 and 3 apart from -2. So we're going to use that as well if you want to put a star next to it or highlight it. We found the midpoint. Now we're going to plug in the midpoint and the perpendicular slope into point slope formula. Y minus y1 equals m times x minus x1. So y minus, x minus. All right, so what's the y that I'm going to plug in? 2. It's 2. It came from my midpoint over here. And then my slope, we said, was 3. We want to use the perpendicular slope. And then my x is from my midpoint, which is still a 1. Good. Now we solve for y equals mx plus b. We're going to distribute 3x minus 3. Add 2, and y equals 3x and is minus 1. So this one is really difficult to comprehend, I guess, if you haven't seen it yet. So what we're going to do is go back to Desmos. What were the original endpoints? the original endpoints.
-2, 3.
-2, 3. And then what was the other one?
4, 1.
4, 1. All right, so here are our, I'll zoom in, pretty zoomed out. Here are our endpoints. What did we find to be the middle point? 1, 2. All right, so there it is in the middle. So we want a line to cut through the midpoint at a 90-degree angle. And on my screen, I'll connect the dots so you can see. This is a segment. Pretend that it was straight. I did my best. What was our final answer? Y equals
3x minus 1.
3x minus 1? Okay, there you go. So if you see, it goes through at a 90-degree angle through our midpoint. And that is a perpendicular bisector. Questions? Okay. We got one more. You're going to try it by yourself. I would check your slope. Yes, ma'am.
Is my midpoint right?
For this one?
Yeah.
Not quite. This is 3 away from 5, but it's 1 away from -1. That's a negative.
Definitely did it wrong.
This isn't perpendicular. This isn't this. You got it right.